example 3 asks us to expand, so like certain types of problems. It's in the example 1 plus ax to the n, and expand that. So it says expand 1 plus 2x to the fifth and ascending powers of x up to the term in x squared. So, so what we again need to make sure we're looking at is our Pascal's triangle. So we've got 1, this is to the fifth, so that's the first row, second row, third row, fourth row, fifth row. So we're using the 1, 5, 10, 10, 5, 1. So in ascending powers of x, well, you start off, I mean, again, 1 gets all of the power, and the 2x gets 0. But then as you go along, you get 1, 5, 10, oops, that should be squared. And that's what it said. It's sending powers of x up to the x squared term. So this is going to be our x squared term. So if we were to simplify these things down, so this is just 1. This is 5 times 2x, which makes plus 10x. This is 10 times 4x squared, so it's plus 40x squared. And so these types of problems, again, very similar, but normally what you can do is you can notice a pattern amongst some of these things. And so just, again, practice on making sure that, especially if you have a 1, that 2 is going to carry most of the weight. The 2x will carry most of the weight, and so on. So it says find the coefficient of x squared in the expansion of 1 minus 3x squared times 1 plus 2x to the fifth. So we have 1 minus 3x squared and 1 plus 2x to the fifth. So what we did in the unit before is we know that the only way that we're going to create certain types of terms is if they run into other types of terms. So the reason why it had us stop here is that we can create an x term from an x squared. Because if we multiply it, or excuse me, we can create an x squared term from an x squared if we multiply by a constant. We can make an x squared term from an x if we multiply by another x, and like we talked about a second ago, we can make an x squared from a constant if we multiply by an x squared. So these are the only terms that are going to be allowed to make x squared from our other part. So if we were to expand this part out, this is a pretty simple one. This would become 1 minus 6x plus 9x squared. That's FOIL or using the box. Either way is, again, fine. And then we had our terms. It wasn't closed, but we had the 1 plus 10x plus 40x squared, and you know that that's going to ascend. It's going to keep going. But those terms are not going to run into anything to create an x squared term. So if we're looking at our x squared term, this 1 will multiply by this 40. So we'll get 40x squared. We'll have a negative 6 times this, 6x times 10x, which will make negative 60x squared. And then we'll finally have plus 9x squared from here. And so all together, this should make a negative 11x squared. So we have a negative 11 for this coefficient. How could this be useful? Well, if you have a problem that you're looking for very specific information from, if you know how those parts are made, you can avoid doing all of the work and you just look for the places where that part is going to be made. So really sit back, look at the question that it asks you to do, look for what it is that you actually want to find, and use a little analytics to figure that out for yourself.